I'd like to introduce you to Sam Sayer. This is a picture of Sam over here. Sam lives in a small rural area in New Hampshire, not too far from MIT. And Sam's community has struggled economically. It hasn't really experienced a lot of the benefits of technological change that places like Bangkok or Boston have. And when Sam graduated from high school, not long thereafter, he went to work in manufacturing. He's been working in factories ever since. And his job in the factory traditionally had been to operate a machine. This is the entry-level job for a lot of manufacturing workers in America or Europe and even in Thailand. And his role, day to day, was to load and unload metal parts for a cutting tool manufacturer, inspect them for quality, and really make sure that if anything broke, he would get his supervisor involved. Now, one day, Sam's bosses came to him and told him they were going to introduce robotic automation on the factory floor, and his job was going to change. And this is a pretty common story for a lot of workers like Sam, and I think there are two ways he could have thought about it. One is that this is a threat to his job. This is threatening to automate out his role within the company, that he might either lose his job or become less important as a machinist. And the second thought was, maybe this is an opportunity, actually, to take that the automation could take away some of my tasks, but allow me to move into a type of job that required more skill, more creativity, and maybe could earn a higher wage. And this sort of dilemma, these two different directions that automation and new technologies can take workers, is the subject of my research and the research of others at MIT. And we think about it as kind of a fork in the road. It's a fork in the road for people like Sam, but it's also a fork in the road for the companies that employ them, that there's a choice between adopting technology in a way that might increase productivity, but actually makes jobs lower quality. It de-skills them. It doesn't necessarily contribute to increased wages. And we've seen this type of commodification of work in a lot of cases. In some cases with the introduction of computers, in some cases with the introduction of new machines that took craft out of manufacturing, that made these jobs less skilled. And you could certainly imagine robots doing that for a worker like Sam, that his knowledge that he's acquired from years in manufacturing isn't really codified in the robot, and he is really just a glorified babysitter for the robot in his role, and his wages go down. And we've actually seen this in the automotive industry in the US, where there was a really dramatic introduction of robotic automation in the 1980s and 1990s, inspired in part by Toyota and other companies, but wages didn't go up for manufacturing workers in the automotive industry. The required skills didn't necessarily go up either. So we didn't necessarily see, we saw more of this path of the commodification of work in the automotive sector. But there's an alternative story, and a story that I think most of us in the room would agree is more desirable. And it's a story in which workers like Sam, when automation's introduced, they experience more opportunities to grow in their jobs, grow into higher skill, higher wage careers. I think this is kind of the socially desirable outcome from technologies like robotics or AI. So the question is, I think the question for me at least, and I hope some of you are interested as well, is how do we take this right path versus the left path? And also, is this right path both better for workers and better for organizations, or is there some kind of trade-off? So that's been the kind of driving question for a lot of our research over the past decade or so. And what I think is interesting about this current moment is that we have some pretty good data on this fork in the road when it comes to robots. We have some pretty good data when it comes to computers and even the internet, but we don't really have much data at all, much insight on this avalanche of new technological progress in the area of AI. So I want to talk a little bit about the lessons we can learn from the first couple of years of LLMs being on the market, and also from more narrow AI technologies. So many of my colleagues have talked about this. You heard from Eric about kind of the impact of AI as a technological system at a society level. You heard from George and even the previous panel about how organizations are adapting to AI. And I want to zoom in even further on the individual level and think about the impact of these technologies on workers like Sam. And I think there are kind of three hypotheses that I want to walk through with you. The first is, will AI, or under what conditions will these technologies improve worker productivity? Will they make workers, I think about productivity in a pretty specific way, will they allow workers to provide more value added for the company's bottom line per hour that they work? So this isn't just being able to do a task faster. Doing that task faster needs to translate into more value for the company, right? And this isn't necessarily a priority for Sam, but it's a priority for his employer, and it might translate into higher wages. The second is what jobs are affected. All jobs aren't necessarily going to be affected equally. They aren't by any technology. So the question is, will the jobs of today, which jobs will be more affected than others? And there's some conjecture that office jobs, even higher wage office jobs, might be more affected by AI technologies compared to technologies like robots. So I want to investigate that with you a little bit. And then finally, there's this question of skills and training that's come up over and over again today, which is, what type of skills might you need to work successfully with AI? There's this trope that's gone around with companies is that you're not going to be replaced by an algorithm, you're going to be replaced by a worker who knows how to use that algorithm really well. That the skill is really to be a successful operator of the technology. And I want to push back a little bit and question that in the course of today. So how might we evaluate these hypotheses? What resources do we have to talk to them? So one is we have history. So we have some experience with understanding the impact of technology on productivity. The second, we have some original research that comes from our surveys of workers and our work with about 60 companies tracking their initial experiments with generative AI. And then also we have a legacy of doing really interesting human AI interactive work at MIT. This is a course that I co-taught last year with Julie Shaw on how humans interact most successfully with automated systems. So we have a framework from the past that was applied in autopilot situations for in airplanes. That's been applied to air traffic controllers. That's been applied to security agents at the airport. A lot of airplane examples, partly because it's taught in aeronautics and astronautics at MIT. But nonetheless, we have a framework for thinking about how these might play out in the future, even though this is a new technology. Okay, so what makes this new or different? Why might some of these past frameworks not apply to the present? And the really terrific introductions to the technology from Eric and George were useful. If I could summarize them in one plot, the difference is really that technologies like Sam's robots that are replacing him, they're really good at doing the same thing over and over again. So they can load and unload a machine very consistently and reliably as long as they have a dedicated power source. But the role for Sam and the role for humans is to add flexibility to robots. So for industrial robots to be really useful, they need a human to reprogram them, to understand where in a process they might be most effective, and to engineer around them, right? So that's the role of the engineer or the really skilled technician. Now, as you've heard from example after example, generative AI is very flexible. It's almost a uniquely flexible technology in that it can take in all sorts of input, can provide all sorts of output, answer any type of question in different languages, but it's not very robust. It might be becoming more robust over time. A lot of these cases of robustness actually sacrifice some flexibility. So you could see some AI technologies that are over here. But in order to make the technology become much more useful or robust, oftentimes you have to rely on human skills, right? So the role of the human, instead of providing flexibility and problem solving in the area of an engineer, the role of the human with generative AI is often to add a layer of robustness, to interpret what the algorithm is giving you and making sure that it's correct or that it's useful, and to act upon it. So you might think this could change with agentic AI. I think we should wait and see on that. So I might table that for questions. And I think an illustration of this, which some of you might be familiar with, is the strawberry problem that's manifested for OpenAI over and over again with their GPT products. How many of you have heard or encountered the strawberry problem? Well, okay, so some people know it. You might, I don't know how they originally discovered this, because I don't know who asked how many R's are there in strawberry. But nonetheless, when you ask ChatGPT how many R's are there in strawberry, inevitably, if you ask in a particular way, it'll get the answer wrong. Very basic question. And then if you ask again in a different way, it'll get it right. It'll give you inconsistent answers over time. So this is just kind of an ongoing conversation that I've had about strawberries with an algorithm, which might require additional therapy or something to investigate why I had such a long conversation about strawberries. But nonetheless, what I think this problem indicates is a broader challenge for these sorts of tools. The broader challenge is this, that the engineers at OpenAI, which have built such a brilliant technology that has so many different applications, know that this problem exists, and nonetheless they can't fix it, because they don't really know why it manifests, what's going on under the hood. This is the problem of explainability and transparency that's come up in previous conversations. That even a simple problem like this isn't necessarily fixable without engineering an entirely different model. So I think for organizations, as long as you know when these errors come up, it might be okay to use it, or if these errors are low cost, but nonetheless, the inability to explain why these errors manifest and avoid them is a consistent challenge, and that's the challenge of robustness that I mentioned. Okay, so to give you a little background on how we've tried to understand these problems, myself and two faculty members at MIT, Kate Kellogg and Julie Shaw, we had all done research on automation and its impact on work in the pre-period, before 2021. Myself in manufacturing, Julie in manufacturing and aeronautics, and Kate Kellogg in healthcare. And what we decided was that we wanted to study in a systematic way the impact that these new technologies were having on workers. And we wanted to see if a lot of our assumptions from these other industries and contexts and technologies would apply to LLM. So what we did is we started to call companies with the help of ILP. We convened a group of about 60 companies to track just how were they using these tools, what effects were they having, what trade-offs were they seeing. And then we also did some additional research and leaned on the research of our colleagues over the past year or so. And I think the lessons from this research, now almost a year and a half on, are really instructive. So what I want to walk through are 5 lessons from this research and give you some of the data behind each. So the first, and these might be of no surprise to you, is that there are some use cases where these tools seem to be really effective in delivering on their promises. Now, there's a bigger question of whether these use cases can generalize to the economy as a whole, but I'll go through a few use cases. So early on, 2023, so now almost 2 years ago fully, there were initial studies of where these tools could improve productivity. So this on the left is a study from 2 economics graduate students at MIT of a writing task. So essentially they had one group of people who were not professional writers try to write a press release. So the one group wrote it just on their own with a little bit of information given from the researchers, and then the other group used it with the assistance of a ChatGPT-like tool. And what they found was not only that did ChatGPT make the writers faster, they also made the press release higher quality when judged by independent experts. Right? Not surprising now. This is one of the earliest studies published in Science. It's kind of the baseline of what happens to your productivity when you use this tool. The other finding that they had, which is really interesting, but has been challenged by later work, is that the poorer writers, the writers with lower quality content without ChatGPT, actually saw the biggest benefit. And they concluded that if you were actually a lesser skilled person in writing, you could see more benefit by using the tool. And this is different from something like robots, where robots seem to benefit higher skilled individuals. They said this tool looked fundamentally different. And that study was really kind of confirmed and expanded in this study, which was of call center workers. So this is the first study of generative AI in the wild at a real call center facility. And what they tracked, what this plot is showing, is the comparison between 3 groups. One group that had a kind of an AI assistant as a call center worker, one group that started out, trained to deal with calls without an AI assist and were given that AI assistant a little ways into their job. And then the final group, the blue group that did this job always manually. And what they found 2 things that were really interesting. One was consistently the red group, the group that was trained to do their job with the AI assistant, they learned to get to a higher level of productivity much quicker. So if you think about this as their learning curve, how many calls they were able to resolve per hour, the red group gets to this like 3.5 level of calls per hour very quickly, whereas it takes the green group and the blue group much longer, almost double the time to get to that level. The second thing that they learned was that there's something fundamentally different between getting trained with this tool, being sort of an AI native in a job, versus learning to do the job one way, learning to do the job on your own, and then having this tool introduced. That somehow there might be something that's hard to transform how you do your job, because the group that received the AI tool 5 to 6 months into their job, they didn't see really any significant productivity benefit. Right? So that was a really, I think, interesting insight. Then the final question that I have looking at this is, does the red line continue to go up? When you have this tool, can you become far more productive than someone who has a year of experience? Or is the real benefit of using this tool to get to this high level of productivity and then you flatten out? and converge, and it's really just a matter of learning faster. So this, I think, is an interesting study that leaves some unanswered questions, but really shows customer service, and this is consistent in our companies, is a real potential use case for these technologies and has the potential to scale up and improve productivity. Now, another one that I brought up earlier, GitHub Copilot. I saw many people in the audience have used this in your either your teams or you have used this individually. Here's one of the first studies of it's a randomized control trial of GitHub Copilot used at several large companies. One, the third column here is the anonymous financial institution, and then you have Microsoft and Accenture. Now, the study had a tough time measuring productivity of software engineering. So what indicator do you choose of how software contributes to the bottom line? So they chose 3 instead of just 1. They chose how many times people are pulling code requests, how many commits, and how many builds. And then their measure of quality was the success rate of those builds. And what I found really interesting was that every time I talk to someone who's using GitHub Copilot, they talk about how amazing it is, how transformative. So I was expecting to see consistently positive and really large productivity gains across the companies. But one thing that I found fascinating was at Microsoft, where this technology was developed in partnership, they didn't actually see a significant increase in builds. And they only saw a significant increase in pull requests. So people were taking on more work. They weren't necessarily delivering more work. And at Accenture, where they did see a significant, actually a huge increase in the amount of new applications they were building, they actually saw that those builds were of a lower quality, significantly lower quality. Now, when you pool all these together, you see what look like productivity increases, but there's a certain trade-off and inconsistency here. So I think again, these are suggestions of positive results, but we need to dig a little bit deeper and understand why are these results inconsistent? Why aren't these companies, which are using the same tool, experiencing some of the same benefits? So that leads me to the second big lesson is understanding how individuals are using these tools in different ways and how their performance might differ. So here is some of our original research. You could look at the whole paper online. And we really tried to understand how workers were using these tools by asking workers themselves. So we had this great opportunity to field a survey of 9,000 workers across 9 different countries, and to try to understand why were some workers seeing more benefits from these tools, and why were some workers more resistant to these tools. And I include in these tools generative AI, more narrow AI applications, robotics. We asked about all sorts of different technologies. And here's a bit of what we found. So overall, we asked about how workers saw the impact of automation and new technologies like AI on 5 different aspects of their job. And I'm going to come back to these factors a little bit over and over again, so I'll go over them. One was, how does it affect your safety and comfort at work? One was, how do you think it affects your pay, your just kind of your earnings at work? That we consider that an important piece of job quality. How does it affect your independence on the job? This is particularly important to American workers. How does it affect your ability to develop new skills, grow in your career, upward mobility? And then finally, and this is kind of the kicker for us, how does it affect your job security? This was our proxy for, do you feel threatened by this technology, or does this technology not affect you? Does it make you feel more secure for some reason? And what was really striking, that across the 9 countries, when we added everything up, we found significant net positives of how workers felt about new technology, that workers were actually, by and large, very optimistic about new technologies and its impact on their work, particularly optimistic about the ability for automation to improve their safety, improve their autonomy, and even improve their upward mobility, their ability, like that right path, so the ability to gain new skills, move into higher wage jobs. They were a little more skeptical of its impact on job security, but really they were still more positive than negative, right? So this was, I think, a really surprising finding for us, that despite a media narrative about all this negative impact that AI and other technologies seem to have on work, that workers themselves, when you ask them, aren't negative at all. Or at least a majority of workers aren't negative at all. So then we wanted to dig a little deeper, like what's happening, which workers are positive, which workers are negative, and what differentiates them. So first I want to break this down by country and maybe throw a little shade at the United States. So workers in European countries were far more optimistic than workers in the United States about the impact of new technologies on their jobs. Very surprising to us. We did not anticipate this at all. We thought that workers in the United States, where a lot of these technologies were developed or being applied early on, would be, given the reputation for openness to new technology and the lack of regulation of new technology, that American workers would be very optimistic. But not so. American workers were, just to compare with Germany, which is kind of middle of the pack, American workers were 15 percentage points more pessimistic about automation's impact on their job security, and 10 percentage points more pessimistic about the impact of these technologies on their pay. Really significant differences, and the United States is very much an outlier in terms of this pessimism. And then you get places like Poland that are just overwhelmingly positive. Workers in Poland where there's a 40 percentage point gap between optimism and pessimism. So what's going on here? We have a few hypotheses. We can't say for sure. We actually have a graduate student looking into this, trying to understand the European and American differences at a more granular level. But the best we can guess is that the job security factor really is influenced by institutions in the United States versus other countries. That because there's not the same social safety net for people who lose their jobs in the United States, the prospect of being displaced by a technology might feel much more real than, let's say, if you live in France or Germany, where there are a lot more protections, a lot more job security, longer tenure for jobs. So that's one explanation potentially for vulnerability. But one thing that I want to underline is that of all the studies we have of the impact of robots and IT on work, suggests that early adopters of those technologies, so companies that adopt robots, they actually end up hiring more people and becoming more productive. So we don't really have good evidence that this displacement would happen at any scale among companies that adopt generative AI. Okay, so the next hypothesis that we wanted to test here was that workers like Sam, workers in positions where they are doing routine tasks that might easily be automated, we thought that they would feel more sensitive, more vulnerable to automation, and they might be more negative about new technologies. So we asked them, so what types of tasks do you do at work? Kind of what's your job like? What industry are you in? And we tried to piece this apart. And what we found, again, was surprising, that we thought that physical workers, so workers in, let's say, warehouses, we talked about food processing before, manufacturing, with a high level of routine tasks, we thought that these would be the most pessimistic workers toward automation and technological change. That actually wasn't the key factor. So yes, if you have a high share of routine tasks and you don't do much problem solving or cognitive work in your job, you're more likely to be negative, right? You have a low perception of its impact on your job security and an even lower perception of its impact on your pay. But if you have that same set of routine tasks, but you do some problem solving, if your job is designed slightly differently, such that you are in charge of, let's say, a cell of robots where you have to make decisions about how it's oriented, then you actually become the most optimistic type of worker. So just that change in the kind of the cognitive side of your job flips your perception of technology, which we found very interesting. That it's actually the level of your cognitive tasks, level of problem solving that you do, that's much more predictive of how you feel about these technologies than your level of routineness. Okay, and then finally, and if there are questions, I'm happy to go into this in more detail. We found a few other factors that seem to be really important, and I'll just mention one. And one of the major factors that it comes up over and over again in studies of human-AI interaction is your propensity to trust. That we ask a battery of questions of people about how much they believe others when they tell them something before it's proven otherwise, how much they naturally trust people. And we have a battery of 5 questions that's now become standardized in the research. And that set of questions, how you respond to those questions, is super predictive of how you think about these technologies, how you think about AI and automation's impact on your work. The more you trust, the more likely you are to think a very positive impact of these technologies and engage with them. Perhaps unsurprising. Another factor that we found interesting, this is more surprising, is that the more exposed you are to these technologies at work, so if you've had experience with robots or AI or generative AI, the more optimistic you are about their impact on your job security. This might be because you're a worker who's already high performing and you're not worried about it, or it could be because you've seen the reality of how hard it is to implement these technologies that you really don't think your company is going to be successful at displacing you. So there are a few kind of takeaways of this for practice that I can come back to at the end, but I think that really the main takeaway I want to emphasize for this paper is job design. That this difference between whether you have a routine job without much cognitive work or whether you have some cognitive work in your job can really make a difference of how individuals interact with this technology. Okay, so the third big point that's come out of our research is about the trade-offs with generative AI. I'm not sure if the free lunch phrase is kind of too slang, but the phrase in economics is there's no such thing as a free lunch. And that's one big explanation of trade-offs when it comes to economic activity. And with generative AI, I feel like the early discussions have been that there's going to be this productivity boom. It's going to be wonderful. And workers can benefit too because they might be able to move into higher wage jobs or more jobs would be created. But the question that I ask immediately is, well, what are the trade-offs? What are we sacrificing here by adopting this technology? So we found a few things. And I think this paper sums it up really well. Another graduate student paper, I would say some of the most interesting work in this field is coming out of young graduate students with creative approaches to these problems. And this is from a graduate student named Aidan Toner Rogers, who worked with a materials R&D company. And he studied how this company, that the job was to discover new materials that were commercializable, how their introduction of an AI tool to help them discover these materials would affect their productivity and ultimately how their workers went about their R&D. Now, mind you, this is a very different case than Sam, right? So Sam is considered a lower wage worker or a frontline worker. These are PhD R&D scientists. Some of you might have a similar job. And what happened, and I'll focus on the lower left here, was he measured productivity in 3 ways. How many new materials did they discover once this tool was introduced? How many patents did those materials turn into? And then finally, and I think this is the key one, how many new products actually came out of it? Because patents, not super valuable always for the company in the short term. Really, what they wanted were commercializable products. And what they found is this huge increase in new materials, more than 50% growth, but a much smaller but still significant increase in product prototypes. So what you can imagine here is they're finding a lot of new materials, and then it's the job of the people to winnow them down into product prototypes. And this assumption that he had that this work is really going to change as a function of this AI being introduced was validated when he asked people, much like we did in our survey, what kind of tasks did you do and how did you allocate your work between these tasks? He found that in terms of idea generation, the workers previously had to generate a lot of ideas. That was a fundamental part of their job as an R&D scientist. But now that the AI was suggesting new materials, they spent a lot less of their time on idea generation, much more of their time on exercising judgment. Is the material that this algorithm is suggesting, is it actually worthwhile? Now, that might be okay, that they're spending more time on judgment, it's contributing to productivity. Maybe that's an okay shift in their jobs. But when he asked them, how did you like this shift in your job? How do you like your new job? They said it was horrible. They hated it. So you look at this really extraordinary change in satisfaction is consistently lower. They really don't like their new task allocation. So this is one of the stories where there's a clear and significant productivity boost for this company as a result of introducing the tool. It's in an area that could be great for society, discovering new materials, perhaps for clean energy or for improvements in manufacturing productivity, whatever it is. But there's a clear trade-off that the workers themselves aren't really happy with it. And I know a lot of you from your experiences could probably imagine that this technology is going to have difficulty scaling if this is the reality, that workers, particularly valuable workers for the company, aren't on board with it and aren't championing it in their own domains. Okay, so finally, I want to illustrate some from our experience. One of the things we found early on when we were talking to companies about their experiments with generative AI, we would ask them, well, how are you measuring success? What does success look like? Can you give us some of your indicators? And over again, these companies would say, we have this many active users. We have this many pilot cases. And that would be their measure of success. We have 10,000 people on our platform. We have this many active users. And it was so dissatisfying because I wanted to know, well, how is that really helping you? How is that helping you do the job that your organization is designed to do? So over time, we wanted to get a better sense of this and like what could it actually look like in practice. And what we found is that there are really limits to this, I would say, sole focus on productivity use cases or doing a task faster. So I want to highlight, there are a few papers that speak to this, but one that's brand new that I find interesting is this study of medical doctors. So they gave, in this study, medical doctors a series of cases that they had to analyze, and then they had, some of the doctors had the benefits of an AI assistant to analyze the cases, some didn't. And then they had their answers were evaluated for their quality. And they also measured the time it took for doctors to analyze. And perhaps unsurprising to you now, the AI-assisted doctors actually did much better on their diagnostic judgment. They did much better at analyzing the cases overall. But surprisingly, it took them longer. It took the AI-assisted doctors longer to analyze the case, perhaps because the AI helped them question their initial judgment and their gut reaction, and that when they deliberated more, they actually were able to provide a much higher quality analysis. Now here, if you were analyzing this in productivity terms, this would be a failure of generative AI and a failure of the process. But really, when it comes to medicine, I think that's not necessarily what you're looking for. The key indicator wouldn't be just productivity and speed. You would actually want quality over speed, because the consequences of an error is so much higher than the consequences of moving a little bit slowly. Okay. Finally, we talked a bit about trust, and I think trust in these systems is really important. And again, one of the things we hear from the organizations we work with is, particularly when we've been studying workers, is how do I get our workers to adopt this technology? How do I get workers to trust it? And I think that's the wrong question, because they're really looking at how do you optimize for user adoption. You want workers to trust the tool. You want workers to use it wherever they can, because you think this tool is going to translate into improved performance, productivity, et cetera. But really, and what we've learned from aerospace and other examples, is that you need not just a blind trust of these tools, you need to trust them when they're appropriate. Now, one of the cases that Eric brought up earlier, which I really like, is this case is from a paper called The Jagged Frontier. And what the authors mean by the jagged frontier is that there are these use cases that generative AI can do well, and there are use cases that these tools can't do well at all, and they might be misleading. So this is a case of Boston Consulting Group consultants given two tasks. Both are typical consulting group tasks, and one, the AI can outperform humans, and then the other, the AI can't. And when they tried to understand why did the AI-assisted consultants fail in this task they considered outside the frontier of what AI can do, they went in and they looked at the chat logs of how these consultants interacted with the algorithm. And they said, well, why were they led to the wrong answer? Like, was it the AI telling them what was wrong? And it wasn't actually just that the chatbot was telling them that the wrong answer. It was when they pushed back, the chatbot was so persuasive in convincing them on behalf of the wrong answer that even these highly trained consultants were convinced to move in the wrong direction. So this is kind of the key, I think, lesson is trust but verify. That you might want to use these tools, but maintain your skepticism of them enough that you calibrate your trust appropriately to what these tools can actually be really good at. And finally, getting into some of your questions, and I really loved reading some of the questions from the other sessions. So if your question wasn't answered, please resubmit it. But one of the things that we've learned, now more than a year in, is that there are a lot of these really interesting unanswered questions that are going to motivate our research, but we're also interested to hear what industry is thinking about with them. So one of the big questions we wanted to know, and I think a lot of folks want to know, is who are these tools most useful for? Who should we be training, assuming we can't focus on everyone adopting them? Are they more useful for novices or experts? Initially, we thought they might be more useful for the lowest skilled individuals, but in software engineering, in medicine, and other contexts, it seems that the skill of being able to interpret the results that you're being given, that skill, which requires expertise, which requires experience, is actually really critical. So there's no clear answer to number one yet. Does training on generative AI help? I've been shocked that a lot of the organizations that are deploying these technologies at scale don't provide a lot of training at all on how to use them. And in one large insurance company we study, they have a 7-minute training before their employees can get on the platform and start using it for whatever they like. So my assumption has been that training on generative AI might not be that useful. And you saw from the previous study that Eric spoke to as well, that workers with generative AI weren't actually that much more likely to answer correctly. And when they were steered in the wrong direction, they were actually more likely to get the answer wrong. So this is, I think, an open question. Does training help, or what training helps might be more appropriate? And then finally, and this was the panel discussed this, is like we don't actually know what the dominant models will be. The models are changing, and what they're good at is changing. So this idea of the frontier use cases are actually shifting in ways that might be unsettling to companies that just want to lock in on a model and have an application that they know can work. So that, I feel like, is I hear a lot of users of these tools say, I just want a dominant design, and I want to know that it can work reliably instead of it changing under my feet. And then finally, I think that this is a key for us as a university and also for the education system in general is, do the skills that we provide need to shift to support people to thrive in an augmented environment? And my initial assumption is not really, that the same skills that help people thrive in today's workforce are going to be by and large the same skills that help people survive and thrive in a workforce that's augmented by AI, because you still need to understand the underlying processes, the underlying technologies that these tools are being plugged into in order to use them successfully. Okay. So I'm going to, given we don't have a ton of time left, I'm going to pause here. And if you're interested in cockpit automation, I'm happy to talk about this more. But I'm going to turn to the questions starting now, and I'll be able to draw on some of the other material. So if we could, now I'm understanding what the other speakers were saying about the clock. If we could throw up the questions. I see one. Did the study design include workers that have been laid off due to automation, or just the ones left on the job? So as someone who studies the prospect of workers being laid off due to automation, there aren't that many clear cases that you can point to. Longshoremen is the classic case. Port workers in the United States are workers that in the 1960s, there was automation introduced at West Coast ports, and there was a huge reduction in the workforce due to attrition and also just because they became far more productive. What the union in that case did was they negotiated that the benefits of automation, the new revenues that came in, would be shared with the workers. So these workers got laid off, but they actually got paid really well as they found other jobs. So the workers did, the study design included workers, people in the workforce, but I actually don't think it would be that much different if we included people who identified as being displaced by automation. Other questions? Practical approaches to training individuals enhances their performance rather than simply relying on AI as a tool. I think, so I've seen a few approaches. So I don't, again, the training point, I haven't seen a lot of good models of training. So we have a partnership with Google. The Google.org funded has sponsored our working group. And they have this interesting approach where they have a series of online courses. Some are the more advanced, like in data science, and they're going to do another more advanced course in AI-related technologies. Then they have this AI Essentials course, which is really to understand. I think Eric actually could have taught the AI Essentials course with his lecture earlier. But it's a series of interactive steps to get the basics of what these tools can do, where you should be skeptical of them, and to help calibrate that trust, which I think could be an effective training tool. But it's not really AI skills. Like, no one's going to be able to work with OpenAI's API after that. No one's going to be able to help develop or fiddle with the weights in a model. So it's not advanced, but it does seem to be useful. And again, I've been struck by how little training organizations, even organizations using these tools successfully, have done for their workers. Are these studies inclusive of agentic tools? No, partly because none of the companies have really used those tools successfully yet that we've been studying. I think maybe you could feel this as an undercurrent. We're studying some very advanced companies technologically. We're studying some very big, kind of Fortune 100 type companies, and these tools have not reached significant scale in these companies to have much of an impact yet, even a year on. So what we're seeing on the ground is hugely different than the hype that we're seeing around kind of the breathless discussions of agentic tools and AGI. It's just not the reality for the companies that we've studied. I feel a bit ashamed. We had so many questions for the earlier folks. How would the AI evolution reshape the education landscape? What would it look like? And consequently, how would this impact on employment? So I feel like I'm going to be hesitant to speculate, but I can talk about what I've heard some colleagues discuss, and I know Eric might have other perspectives. He works with folks in computer science and artificial intelligence laboratory. I think the question is really acute in computer science fields, where I think there are early indications that what it means to be an entry-level programmer in a lot of large software organizations is very different. So traditionally, when a school like MIT would train a software engineer to not only take an entry-level job, but to move up to a leadership role where you really had to understand the architecture of a system, you had to make leadership decisions, you had to understand kind of the overarching technical landscape. Now, a software engineer might be lower paid and also require less skill. So the question, I think, from schools like MIT is, do we really still want to educate our students to go into that entry-level role, or are we going to educate them for leadership and understand that that entry-level role might change but still be a step along the way? So I think that's an ongoing conversation, that as entry-level jobs change, or the skills required to do these jobs change, the curriculum to train students to go into these entry-level roles will also have to change. Okay, in the absence of more questions, I'm going to go into just a final, let's say, a parable to leave you with. So I'm going to only talk about one of these, but on the left, I'm from Chicago. Oh, they didn't even pull it up. Okay, there we go. I'm from Chicago, and one of the things that Chicago is known for is a particular hot dog company. I don't know if any of you have been to Chicago. It's a wonderful place. I would really recommend it. And we make these Vienna beef hot dogs that are known for their red color. I don't know why they're called Vienna beef. You'd think that would come from Vienna and not Chicago, but nonetheless, we're known for producing this hot dog. And given that you talked about food processing before, the factory that produced this hot dog for the longest time was in the city, and it was one of those older factories where the equipment was from another generation, but it was produced in this particular way that people really loved it. They loved it at baseball games, and it sold really well. And one of the things that the Vienna Beef Hot Dog Company did was they realized that the times were changing, and they wanted to automate their processes, partly because of increased standards in the food industry. So they brought in automated material movement, they brought in robotic automation, and they created a whole new facility that was very kind of clean. You can imagine stainless steel, everything. And they started producing hot dogs in the new facility, and the hot dogs looked totally different. They didn't have this kind of red, shiny color. They were gray. They didn't taste the same. And what they found was that they introduced automation, and something went wrong in their process. Something broke down, even though they thought they had replicated everything step by step. And when they went back and they tried to do a root cause analysis, they said, why did this automation kind of lead us to such poor quality? They found that what they hadn't realized as part of their process was that being slow at moving the hot dogs from the station where they were cased to the station where they were smoked, it used to be a guy named Irving who would push the cart, and he'd talk to people, and he'd move nice and slow. And it took a long time for the process to happen, but once the hot dogs got into the smoker, they had sufficiently thawed that they were at the temperature to produce this red color, to produce the taste. That it was actually the slowness of the process and Irving's maybe, lazy ways that helped them do the very thing that they had become so good at. And once the automated system cut this time of the process in half and just dunked the hot dogs right in the smoker, they had lost what made them special in the first place. So I think this is, I think of this real story as a parable for what many organizations are doing now with AI tools, that they're in this desire for speed, in some cases losing what brings their business value in the first place, and loses what makes their workers and their skills so valuable as well. So I think understanding kind of the core processes, the core technologies that makes organizations great is important far before you figure out what technologies might be helpful for those organizations. So thank you so much for your time. Happy to talk more, and really appreciate you coming.
Thank you very much, Ben.